We're going to show how to use Desmos to find a nice picture of the contour diagrams. And then we'll try to follow that up with what we can do to actually make them really useful. Meanwhile, the function we wanted to do was something like this, square root, x squared minus y squared. Of course, it didn't actually do anything. What I want to do is we always want to, in a contour diagram, set it equal to some constant. What I'm going to do is over here set it to constant equals a. Now, what Desmos usually does is says, hey, let's put in a slider for a. If we put in a slider for a, we get one little contour thingy, but we want some evenly spaced, and we want to be able to pick them. So what I'm going to do is actually get rid of the slider, like this. And what I'm going to do, and you're going to have to remember the syntax, I want to say a equals, and I'm going to use square brackets, and then pick some nice values of a. And I think I picked 1 through 3 before, 0 through 3. So let's do that. So 0, dot, 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 comma, 3, like that. And you can actually see the ones we got before. If I wanted to actually get quite a few more, I could do something like that. And you get pretty much the diagram we got that was before. Now, the only issue is that in order to use this for calculus, we have to know the z levels of each of these, which brings up why we have to be able to do this by hand, right? We need to be able, in order to do calculus with these, say that the z level of the first one was actually 1, the z level of the second one was 2, the z level of the third one was 3, and then we can do all the calculus that we want to with this. So between getting Desmos to draw the nice picture and drawing enough by hand so that we can figure out what the z levels are, we can do a lot of good calculus with this. The end.